So we did a live stream from the David Dunlap Observatory on the topic of the Perseids, not to show Perseids, but we did have participants that were sending their views. We had an all-sky camera somewhere, I think the Newcastle Observatory all-sky camera. But after it was done, I did stand outside for a while and look up because there's a lot of sky at the DDO. It's nice that way.
Oh, yes, there is.
But I didn't see a single one. So that was the Saturday night, not the Friday night.
It wasn't. Hello, YouTube. While everybody's starting in, we are just talking about our Perseids experience. I didn't think it was as plentiful as I've been other years looking at them. I did see a huge one streak across the sky, like you couldn't miss it. And that was probably my most impressive one. And part of me wanted to bring out my sketchbook and draw the path. But okay, seems like we're out. So welcome back to our August episode of Insider's Guide to the Galaxy. We hope you're all getting out in the nice warm weather and stargazing. I know there's quite a few star parties coming up in the next couple of weeks, and there has been already. So hope you take some stuff you learned from this and then go out and try to look up at the sky. So I'm just going to jump right. I have nothing from National to announce, so I'm going to just let Chris jump right into it. Let's get started looking at the planets.
Thank you. Yeah, so it's planet season has kicked off. As of this week, we have 3 planets in the sky by midnight, sort of naked eye planets, and then there are actually 3 more in the evening and 1 more in the morning. So we'll cover all of that. So really, you can see lots of planets if you time yourselves, if you want to spend, dusk till dawn checking them out. Yeah, so one of the main reasons that we're here is that this week, Saturn is at opposition. And for those that aren't aware, opposition is the best time to look at planets because that's when they're closest to Earth. They're opposite the sun in the sky, which means both that planet and us are on the same side of the solar system and then closer to one another. So that's a great time to do that. Opposition means that a planet will rise as the sun sets, be up all night long. It'll be at its brightest, largest in telescopes, give you the best opportunity to see any fainter features around it, like more of Saturn's moons or maybe Neptune's moon Triton, things like that. So that's a great time to make the effort to get outside. So let's just sort of set the stage. I'll share my screen here and bring up Stellarium. So this is the sky right now, and what we're going to do is we're going to pop it into the evenings, let the sun go down here. And by the time we get to, now I'm doing Toronto, but I'm going to reference some other cities for some events that are coming up over the next little while. So what you can see here on the screen is I've got a view of the southeastern sky. The yellowish line, or kind of a yellowish creamy line, that's the ecliptic. Now the ecliptic is actually Earth's orbit as expressed across the sky, of course, but most of the planets, plus the sun and the moon, hang out within several degrees of the ecliptic. So that's why for us in Canada, you're always going to find the planets in the southern half of the sky. If you see something really, really bright and it's up near Polaris or in the north, it's not a planet. It might be ISS or some other, event that's happened there, but it won't be a planet. They don't wander that much. And along this line here, I've got this label called ASP. And ASP is an option in Stellarium. If you go into the F4 viewing options, hit the markings tab, you can put a check mark in any of these little boxes to highlight the marking. This is the anti-solar point. So that's the point in the sky exactly opposite the sun. And you can see that Saturn is close to it. And in fact, Saturn was at opposition a couple of nights ago. So on the 14th or so, Saturn was at opposition. That's kind of why we're here. Now, if I bring the time up a little bit later in the evening, there you can see Jupiter's coming up, and I'll just wind this up a little bit later. Here we go. So Jupiter, last year, you might recall that Jupiter and Saturn were kind of partnered with each other. But because Jupiter orbits the sun about every 12 years and Saturn takes 30, then that means that Jupiter outpaces Saturn across the sky. So a couple of years ago, we had Jupiter to the west of Saturn, then we had them near one another. And now from each year out from here, they're going to get wider and wider apart. But right now for this summer, you're going to see Saturn and Jupiter about 45 degrees apart in the sky. So, and they'll actually vary a little bit because of prograde and retrograde motion. So right now, they're both actually moving retrograde. Retrograde motion, let me just bring up a diagram here so everybody can see what I'm talking about. All righty, here we go. So retrograde motion happens when the Earth, everybody's orbiting the sun here, when the Earth passes an outer planet on the inside track. And because the Earth is moving faster, being closer to the sun, then it makes the planet appear to reverse course in the sky. So normally the planets will migrate easterly through the stars, but when Earth is passing them on the inside track, then they'll appear to go west for a while, and then they'll pause and then return to easterly motion. So right now, we're at the point where Jupiter and Saturn are already in their retrograde motions. And obviously, once you start moving retrograde, there is the point where the Earth is in line with that planet, and that's at opposition. So opposition always occurs midway between, midway through that retrograde loop. So they're going to be, Saturn and Jupiter are going to be kind of hanging out together all year. They will creep to within about 39 degrees of each other at the end of December as they both sort of finish their retrograde loops and return to their normal sort of standing. And then they'll widen up again after that. And so I had this neat web tool if you're interested in plotting that kind of thing up. So here's where you could say, take a planet, Jupiter, or I could even put in Saturn here, and ask it to plot their angular separation from each other over 1 year. And you could put different years in here if you want to, different durations. And so you can see that right now, they're this far apart, 47 or so degrees. Then they're going to close to within about 38, and then they're going to start widening into next year. So this is a neat tool. Thought you, and Samantha could put that in the chat. So that's great. So we've got Saturn. Now Saturn is actually visible at dusk. So because it's at opposition, that means it's available at sunset, clearing the horizon at sunset. And we can watch it all night long. And I'll come back to a bit more details about that in a bit. Then we've got, later in the evening, we've got Jupiter. It's actually rising around 10 o'clock. And then an hour or so later, a couple hours later, we've got Mars and Uranus coming up. And then if we wait all the way to the dawn, then we get Venus. But let's rewind a little bit just for sort of completion's sake. And we'll go back to, there's tonight's sky, so the 16th. Let's go back to around 8 o'clock and look west. And this is where you're going to find Mercury, if you're lucky. And Mercury is in the midst of an apparition. Here we go. I'll get rid of the trees here so everybody can see it. There we go. So Mercury's been hanging out in the western sky after sunset for a couple of weeks now. It'll be there for the rest of the month. But you can see that the ecliptic is really tipped over, really inclined. And Mercury itself, I'll just bring up its orbit here, is actually sliding even below the ecliptic over the next little while. So let's just draw the orbit here. So it's actually just being hugged close to the horizon after sunset. So we really have poor apparition of Mercury for us at the present time. But if you lived in the tropic, or if you live in the tropics, or if you live in the southern hemisphere, the ecliptic is vertical and you're getting your best views of Mercury for the year right about now. We're going to get an excellent appearance of Mercury in September. So Mercury's going to swing back to the sun and then revert back into the morning sky. So let's just bring this to September 27th or so. And I think I'll go into the morning sky. So you can see by the time we get into late September this year, the ecliptic is very vertical, and you can see you've got Mercury and Venus hanging out together, and they'll actually get better and better. So Mercury's going to get higher and higher as Venus drops away. And so we'll get a really, really nice chance to see Mercury if you don't mind getting up in the morning. This is 6:45, so it's not too bad. And you'll be able to see it, shining in a dark sky around 6:30 a.m. And then the planet's going to put on a final show. So it'll finish its morning visit. It'll pop back into the evening sky for December. So let me just jump into December here and go back to evening sky. Let's see if we can find Mercury here. So there's Mercury, and we're going to get Mercury hanging out with Venus. So right at the end of the year. So they'll be actually closest to one another. Let's see. So mark your calendars around the 28th of December. Hoping for clear skies, a nice, I think that's telescope close. So they're going to be about a thumb's width apart, or about less than 1.5 degrees apart. So that'll be telescope close. Of course, taking all the usual precautions about making sure the sun is fully set before you look at Mercury in the evening sky. All right, back to now though. The other inner planet we've got is Venus. Let me just put this marker on here. Go to Mercury and go to Venus. So if you're an early riser these days, go back here to August. Venus is hanging out in the pre-dawn sky. It is already starting to head sunward. So it's going to last another few weeks. It's going to get harder and harder to spot, between the trees and the houses and things like that as it drops lower every morning. But it's really bright, magnitude minus 3.85, rises about 5 a.m. But that's going to be less and less visible as we go. If you do want to check it out in a telescope, it's nearly fully illuminated. So there's a little bit of darkness on its western side. And you might notice that this is the beehive cluster. So actually, Venus is actually hanging out right now. Tomorrow morning, the next morning, right beside the beehive cluster. Not optimal for us to see the beehive cluster from mid-northern latitudes, Canadian latitudes. But if you live in a southerly place or the tropics where the sky will be dark, then you'll be able to see that cool scene of them sharing binoculars.
Sorry to interrupt, Chris. We're just having some technical issues right now. Can somebody in the Q&A or in the chat, people see the chat now? Some setting got flicked in our Zoom account that did not allow webinar chats to be enabled. I tried to flick it back, but if somebody could just let me know in the Q&A if it's back or not.
Somebody try a chat. Try putting something in the chat. No, I'm not seeing anybody so far.
Oh, still it's disabled. So unfortunately, it looks like
Q&A works though.
the Q&A works. Are people getting chats from us as hosts? So everybody's getting, so the chat is not back, but okay. So what we're going to do for the time being, because I think this probably involves us restarting the webinar if we want to bring the chat back up, and I apologize. If you can't see the chat right now or use the chat box, just use the Q&A stuff and I will get rid of them as necessary. I apologize for this technical difficulty. This happened at the back end.
What about people raising their hand if they have a question?
Oh yeah, you can also raise your hand if you have a question.
Okay.
People raising hands works. Well, if they have a question and they raise their hands, then we have to unmute them to talk.
All right. see if we can
So feel free to use the Q&A for chatting or talking if you want to communicate anything with us. I sincerely apologize for this issue.
All right.
I think everybody can see the chat. The
Okay.
quick Q&A, sorry.
So pressing on. So we're finished with the inner planets. As I indicated earlier, we're going to lose Venus the next little while, and eventually Venus will reappear towards the end of December in the west after sunset and do a little dance with Mercury at that time. So we're going to put those aside and focus mainly on Saturn and Jupiter and the other planets up in the evening sky. So Saturn is going to be hanging out near the stars of Capricornus all year long. Now, these stars aren't very bright, so you may have noticed the two little medium bright stars below Saturn over the next little while. And what you can do is, if you pay attention to Saturn, you can actually note it. Let me just see if I can center here. You can notice Saturn.
Oh, sorry.
Go ahead.
We just have a question about Venus.
Okay,
now
go
that
ahead.
we have people. Do we need a specific filter to view Venus, or is there any specific tricks with such a bright object?
Yeah, well, to see Venus nicely in a telescope, you want to try to catch it when it's higher in the sky or higher above the horizon. And so you kind of need to wait for favorable apparitions of the planet. Beyond that, you don't need anything special. It's just that when it's very low, then it will swim in the eyepiece. You get a lot of air turbulence and things like that. So for example, you can see here in the stellarium, when you pick an object, there's a line here that says reduced to something by so many air masses. So if you look straight up, you're looking through one air mass. But if you're looking low in the sky, you're looking through multiple thicknesses of the Earth's atmosphere. Mm-hmm. And as you can see at Saturn, around 9:30 tonight, we'll be looking through 5 times the usual amount of air, 5 times the air's thickness. And the more air you put between you and the object, the less clear it looks in a telescope. So typically an object like Mercury or Venus, when they're just above the horizon, you could be looking through as much as 10 air masses, and you really get a lot of that blurriness and swimming. But when I pointed out that Mercury apparition that we're going to get in September, where it's right above the horizon at 90 degrees, so it'll be nice and high and much clearer views at that time. So that's kind of the rule of thumb.
Perfect. Thank you.
Yeah.
And the chat is back.
Oh,
I fixed
the
it.
chat is back. Fantastic.
I am so sorry. Never had that happen before. So, okay, let's keep going with Saturn.
Yeah, so you might have noticed Saturn has got these 2 little stars. And because Saturn is moving retrograde, that means that compared to those stars, it's actually traveling west. So you'll see it move with respect to those stars over the next little while. And eventually Saturn will finish its retrograde loop. It'll actually get to about here near theta cap. So it'll swing out like this, and then it'll pause, and then it'll wind back again for the rest of the year. Probably by the time we'll probably almost lose it at the end of the year. So right now Saturn is rising about 8 o'clock or so, right? It'll be it's just about opposition, so that means it's closest. So at opposition, it's 1.35 billion kilometers away, 3.25. It's 73.7 light minutes away, and it's shining at magnitude 0.28, so it's brightest for the year. And the other neat thing about a planet like Saturn at opposition is that its brightness is enhanced by a phenomenon called the opposition surge, or the Seeliger effect. And it's a backscattering effect from sunlight hitting particles and then preferentially reflecting straight back towards the sun. And so if the sun is behind your head, then you get that enhanced view. So you can go on to you can do a Google search of the Seeliger effect or the opposition surge of Saturn. You can see sets of pictures where the rings are suddenly brightest at opposition, and then they fade a few days later. So it sort of peaks up and then comes down again. There's actually a link in the notes that you could share if you wanted to, showing kind of a graph of how Things get brighter as we get closer, but then they get extra bright because of the Seeliger effect. You can also do that by, if you take a picture of the ground with the sun behind your head, you get this brightness around your shadow. That's the same effect. Okay, what else? So yeah, so we're getting, the best time to see Saturn is when it's highest in the sky. Again, it's that air mass effect. So if you look at something like stellarium, it'll tell you that the planet will culminate or reach its highest point in the sky around 1:15 a.m. So you could start looking right after sunset, but the later you wait, the higher it'll climb in the sky. So if I go to 9 o'clock, 10 o'clock, 11 o'clock, 12, so about 1:30 a.m., Saturn is over the southern horizon, and it's about 31 degrees or so above the horizon. So we're down to less than 2 air masses of air in the way. So that's a great time to look. Now, the great news, though, is that that time that it's highest, the best time for telescope viewing, actually advances by an hour every 2 weeks. So it's going to get much, much more convenient to look at as we get deeper into August and September. We can actually keep watching Saturn in telescopes till about early January. By that point, it'll still be in a dark sky, but it'll be sort of dropping into the western horizon after sunset, after dusk.
So we have a question. What is the smallest scope we're able to see the Cassini division in or with?
Ooh, tricky. Okay.
The question was, can we see it with a small scope? But I think
scope. Yeah, so there'll be kind of 3 considerations. One is make sure you're viewing it through the minimum air masses. Mm-hmm. So you got the cleanest view of it. Number 2 is you want night with good seeing conditions on top of that. So you want the air to be as steady as it can be, plus as least amount of air as it can be. And then you want a sufficient aperture telescope to resolve it. So what I'm kind of dodging is that even if you have a very small telescope, you could probably see it on a really a good night.
Yeah.
And even a bigger telescope would have trouble seeing it on a night of poor seeing.
I can confirm that. As I was saying, I went out on Friday night with an 11-inch, but we were watching it around 10 p.m. and it was kind of cloudy, and it was in the city, and we couldn't see it. So. Yeah. That's very good points. But if I was probably on a clear night in a dark sky preserve around 1 a.m., 2 a.m., then I might have been able to see them with the same scope.
Now, just for those that may be wondering what we're talking about, I was going to cover this a little bit later, but
I'm sorry.
No, it's fine. It's fine. So the rings of Saturn are not uniform. It's not just one ring around the planet. There are multiple rings around the planet, and there's generally A, B, and C. Are kind of the 3 main sets you see here. We've got a set here divided by a dark gap, another ring, and then a dark ring that's in here as well. And so the Cassini division is this division that divides the 2 bright sections of the ring. So yeah, that's something really, really great to look for when you're looking at Saturn. I'll talk about some of the features.
Yeah, so even the magnification, the follow-up question would all depend on what your viewing conditions are and when you're viewing it.
Yeah, I'm going to share some ideal magnifications as we go.
Okay, we'll talk about that later. Thank you.
Yeah, and if I forget, just remind me. Let's see, just finishing up on Saturn. So I said we could watch it for the rest of the year. Yeah. Oh, the other neat thing is that, Saturn is at its best at opposition, as we talked about, but because Saturn is, running around the sun in its orbit every 30 years, then as each Earth year passes, the planets migrate east along the ecliptic, basically. So Jupiter orbiting the sun in 12 years basically jumps a month's worth or a zodiac constellation every year, right? So Jupiter's here in Pisces. Last year it was in Aquarius. The year before that, kind of here. Saturn being slower, it takes, 2 years to do the same thing. So as every year goes by, Saturn's opposition will migrate 2 weeks later, right? So that will mean that when a planet is at opposition during the summer months, the ecliptic is low in the sky. And so it doesn't get that nice height that we like to see to get the clear view. So Saturn being only 30 degrees above the horizon, 2 air masses, when it's at opposition in August. But several years from now, Saturn's opposition will be, let's say 4 years from now, Saturn's opposition will be happening, in September, early October, that kind of thing, getting into the autumn months when the ecliptic is higher in the evening. So it'll actually be higher in the sky when it's the best time to see it. So over the next few years, eventually we'll get it into the kind of late autumn and winter months, and it'll be cold as heck to look at it, but it'll be nice and high for Canadians in the sky as opposed to these summertime oppositions.
I think the ideal time for me for viewing is autumn because you don't have to stay up too late and it's not cold. So that's what I'll be waiting for.
Yeah. All right, let's talk about a bit about Jupiter. So Jupiter isn't at opposition yet. It started its retrograde loop, but it won't reach opposition. See, it's got to reach this ASP point. So if I advance the dates here, you can see Jupiter is approaching, and it'll actually reach its opposition on September 26th. So then it'll rise at sunset, stay up all night. It'll be 591 million kilometers away, or 32.9 light minutes, and it'll reach a max brightness of -2.4. Now, what's cool about Jupiter is that, Jupiter has an elliptical orbit around the sun. So just like Earth has a perihelion and an aphelion, so did the other planets. And Jupiter is going to reach its perihelion in January of 2023. So at that time, it'll be the closest it gets to the sun in its orbit. And because of that, when we're at opposition, we'll be closest to it, but it'll be also closer to the sun. So the gap between Earth and Jupiter will be a minimum. And so Jupiter will get bigger than it typically is. So already this year at opposition, the size of the planet's disk is going to be around 49, almost 50 arc seconds. But in 2023, it'll get up to, where are we at? We're at 40, what did I say, 40, 49. Yeah, so a year from now, it'll be even bigger, almost 50 at opposition. And then it'll start getting smaller again as we go from there. Yeah. So that's something to keep an eye on. At this year, Jupiter will get to a height of 46 degrees above the horizon at opposition night. So here we are transiting at about 114, somewhere around here. It'll be over the southern horizon, and it'll be a bit higher, quite a bit higher than Saturn was. And that's because Jupiter is already ahead of Saturn along the ecliptic. And so it'll be only 1.4 air masses when it's at its culminating point. What else is cool? So we'll be able to watch Jupiter until, let's see, until about well into the year. So let's just advance the time here. Let's go ahead and watch this as it migrates into the western sky. So we'll be able to watch it way past Christmas. So well into next spring before we lose it. So around, by the time we get into February, it'll start to be shining in a twilight sky.
So does this mean we're going to have a better year for planets in the evening next year compared to this year?
They'll be, well, the timing will be different, right? It'll be more, they'll be more like autumn season, planet season, as opposed to late summer planet season. But yes, they'll be generally higher. So that's great.
Because this year we didn't have, a lot of the year didn't have a lot of planets in the evening.
Exactly. Well, part of the reason for that is, of course, is to do with what Mars does, where Mars disappears for a while. So we'll come back to Mars here in a bit. But yeah, let's see what else can we say about, so we're going to get, actually, you might have noticed that Jupiter is going to meet up with Venus, very close to Venus on, let's see, the end of March 2023. So there'll be almost like the Christmas star effect, where there's two of the brightest planets sharing the same little patch of sky. And of course, if you like the photo ops of the moon posing with the planets, we're going to get lots of opportunities for the moon posing with Saturn and Jupiter and Mars this fall. I've got binoculars close on October 8th, November 4th, December 1st, that kind of thing for the moon and Jupiter. All right. Okay, let's talk. How's our time? Okay, we got a little bit of time here.
We have a quick question about Saturn, going back there from our YouTube. How long is the Saturn being like extra bright going to last? Is it like a week, or is it a couple months with the effect that we shared?
No, it's really only, I think it's only really within a day or two. Yeah.
Okay.
So if you graph it up, I'm not sure if I have the graph handy, but you know, the planet will increase in brightness as we approach opposition and then decrease as we move past it. But instead of the top of that peak being round, it's got a little extra peak on it.
So we're
right
looking
at opposition.
almost right when it's at opposition. Does that happen?
Yeah.
So has this already passed for this time?
Yes. But if you go back, as I said, you can find lots of people that have taken sequences of photos that show the rings brightening up.
Thank you.
All right. Let's talk. I think we have time. We can talk about Mars. So Mars is still late night, but by no means we don't want to count Mars out, because this is the year that Mars comes back and does some really cool stuff for us. So as of right now, this is tonight at 1 o'clock. So Mars is going to rise in the east at around midnight, and it'll get about 2 minutes before midnight, 2 minutes earlier progressively each night after that. Normally things rise about 4 minutes earlier each night, but because Mars is swimming east while the sky is migrating west due to Earth's motion around the sun, then it cuts about half of that difference, and we only get 2 minutes benefit instead of 4. So it's going to be hanging out here in Taurus, and there'll be a nice scene with the Pleiades here. Let's see, there's a nice visit with the moon on August 18th, 19th. So there's the moon with Mars and the Pleiades on the 18th and 19th. Mars is not going to be really good for telescope viewing until it gets higher. So here we are looking at 5 air masses at 1 o'clock in the morning. It's not till we get to the wee hours, really, nowadays, that Mars is going to be shining cleanly in the sky. So just before dawn, it'll be clearest in a telescope, but I'll wait a few weeks. The planet isn't actually a full disk right now. It's actually only 85% illuminated. So that's kind of an interesting aspect because of the geometry of the sun and the Earth and Mars. We go on. Yeah, so Mars is going to look brighter and larger with each passing week in a gradual basis. And that's because Earth is kind of catching up to Mars. It's getting ready to do that passing on the inside track. And so that's going to culminate or peak at the opposition date in early December, which I'll come back to here in a sec. So Mars is going to begin its retrograde motion in October. So what I'll do is I'm going to actually unselect Mars. I'm going to flip the sky like this, and we're going to actually watch what Mars does over the next little while. So here's tonight, and you're going to be able to see Mars creeping east every night. Around the 12th of September, it's going to be, let me just bring up some binoculars. Circle here so we can see it. And I'll just center Mars so you can see this here. So Mars will be binoculars close with this bright open cluster, NGC 1647. And then a few nights after that, it's going to pass a similar distance to the south of NGC 1746. By the way, this is the Pirate Moon cluster. This one doesn't have a fancy name.
Would the brightness of Mars wash out some of the cluster, or would be
not yet? No, it's still pretty dim. It's it's getting up there, but it's still relatively modest size. What you can always do in a case like this is you can hide, if the object is bright, you can just tuck it to the outside edge of the binoculars and see if you can see the stars of the cluster better. So then as we advance, here's another neat one. So around the 15th of October, Mars is going to be, I think it's telescope close to M1. Yes, within a degree of M1. M1, of course, is the Crab Nebula. Now, again, Mars could wash out the faint Crab Nebula. Plus, we've got the moon on the 15th, but of course, the moon will be away from them a few nights before and a few nights after. If you want to give that a try, you can certainly try an astro image, maybe 2 different exposures, one for the planet, one for the Crab Nebula. So that'll be fun.
Might help with figuring how to locate it for later nights too. If you
the Crab Nebula.
Find Mars. Well, you can find Mars and then you can go back and locate the stars. Because I found once I've looked at one area in the sky once, it's a lot easier for me to see it another night, even if the target's not around.
Yeah. And so then you can see here, as I advance the date, Mars is slowing, it's making the turn, and now it's heading back. So in November, it's going to be heading back. It'll pass even closer to that star cluster we passed a little bit ago. And then we come up to early December. So here's the deal on Mars. So because, let me see if I can bring up this diagram for Mars. Here we go. This is cool. So this is the diagram that explains the Mars oppositions over the next little while. So you've got the sun in the middle, you've got Earth in its orbit, the green circle, green ellipse. Then you've got Mars and its brown ellipse. And each of these vectors are oppositions. Okay. So on October of 2020, we had a really fine opposition of Mars where the 2 planets were rather close together. You can see the difference in distance between the 2 orbits. And now 27 months later, so the Earth's gone around the sun a couple of times, Mars has gone around just a little bit more than once, and they're lined up again on December 8th, 2022. And you can see that the 2 orbits are diverging or widening in time. And so that actually means that Earth will be closest to Mars about 8 days earlier on November 30th. So technically Mars will be brightest in the sky and biggest in a telescope on November 30th. So bear that in mind. So there'll be all kinds of outreach events and media news, media splash, and things like that. Now, another cool thing that you can see on this map. So you can see that when oppositions occur on this side of the orbit, they're happening in December, January, February. And at that time of the year, the sun is low in the sky and the nighttime planets are high in the sky. But the times when Earth and Mars are really close together at opposition, those are happening in the summer months when Mars is low in the sky and the views aren't as nice. So when we saw the planet back in October, I don't know if you did any outreach events, but you may have found that they had to be really late at night because Mars took a long time to get high enough to clear the trees or clear the buildings. I think we were at the Ontario Science Center and we had to wait till quite late before Mars could show up. Whereas this time around,
webinar with a live view of it online. I think it's recorded if anybody wanted to go back and check on that.
Yeah. So this one is going to be nice. Now, the distance between the 2 planets will be more, but Mars will be higher in the sky. So closest on November 30th, but true opposition is going to be on December 7th. So here's the night of November 30th. And look how high, so I'll just get rid of the deep sky objects here. So for the GTA, for Toronto area, Mars is going to be 55 degrees above the horizon. Well, let's go back to earlier in the night. So let's see, culminates around, here we go. Transits around midnight, so it'll be 69 degrees above the horizon. So really very crisp views of the planet. Only 1 air mass, so it's almost as good as you can get. There's the zenith up here. So that's great news. And then on the following few nights, Mars is going to creep up onto its opposition point. And here's where the real fun happens. December 6th, Let me just go back a couple of hours here. Just bring Mars into view here and center it. Here we go. December 6th, December 7th, occultation of Mars by the moon. So this is going to happen at about 12:55 a.m. in St. John's, about 12:14 a.m. in Halifax, about 10:30 p.m. So I'll just advance the time here. Ding, 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 ding. Almost 10:30 p.m. in Toronto, 9 p.m. in Winnipeg, 8 p.m. in Calgary, 6:53 in Victoria. So this is a huge outreach opportunity for all RASC centers all across the country. And the planet will be nice and high. Let's see, where are we at here? 62 degrees above the horizon in Toronto, quite high in most of the country. So this can be a really fantastic event. Okay, I think that's everything about Mars we want to talk about for now. Any questions on that, or are we good?
Nothing on Mars, but we do have another question from our friends in YouTube. What we've gone over this before. What apps do you recommend to look for forecast-wise to grasp the best seeings, and what kind of key indicators are you looking for if you want to go out a night with good seeing?
I like to use
in particular. Sorry.
Yeah, I like to use Astrospheric, so we can just quickly bring that up. Show that here. There are several apps that do this. And Astrospheric is both an app and a web service. And so what you're looking at here is an hour-by-hour chart versus time. So the days turn over at midnight, obviously, so Wednesday, Thursday, Friday. And the top row represents the amount of cloud cover, where dark blue is clearest and white is cloudiest, and in between. The second row is the transparency. So the transparency is how clean the air is, how free of it is of smoke or moisture, humidity, moisture, that kind of thing. So how clear, how transparent is the air? Again, you're seeing that white is not transparent and darker blue is better. And then the third row here is the seeing conditions. So that's the steadiness of the air. It might be a windy night will give you, terrible conditions, whereas a steady, clear night will get you very good conditions. So I basically, you don't want to only look at the cloud cover. You want to look at the seeing conditions and transparency. So transparency will matter if you want to find dim things like galaxies or nebulae. They won't, they're not going to bother star clusters or double stars or anything like that too much if the transparency isn't super good. But the seeing will matter if you're trying to see something, fine details like splitting a double star or making out details on the planets or the moon. You want the better seeing conditions. So hopefully that helps. That's astrospheric.com. Clear Outside is another one. You'll see that there are different rows for the different elements.
Always a good reminder how to read those charts because they can be overwhelming if you're not used to them. Yeah. We have two other questions. One is, well, obviously the moon will be occulting Mars, but in the process, will the moon be too bright to see Mars, or will you be able to see both, like discern both?
Yeah, I don't think we'll have any trouble seeing Mars. Definitely, and with unaided eyes, when they get very close together, there might be an issue, but binoculars, you'll certainly pick them up. Telescope, you'll certainly pick them up. Yeah.
So good photo op opportunity.
Oh, especially movie. Right.
Lucky video.
You want to get that. You want to get that scene of the planet, second by second. So this is a simulated view, second by second.
And the nice things with the planets is because their moon and planets are so bright, you don't have to have an extensive astrophotography setup to be able to get some idea of what's going on up there. We have another question back to seeing Saturn and Jupiter, and I know you're going to dive a little bit deeper into it, but would an ND filter or a neutral density filter help with looking at them at all?
Yes, and I'll elaborate in a bit.
Okay, sounds good.
Yeah.
And that's it.
Okay.
For questions right now.
So let's go back to, let's just, for completion's sake, let's just finish the planets that are available in the evening time. So right now we've actually got Neptune hanging out near Jupiter. So Neptune is on the kind of on the line here between Jupiter and Saturn, closer to Jupiter than Saturn. So there's Neptune is right about here. Neptune is only magnitude 7.8. It's very star-like, point-like in a telescope, but it is theoretically visible in binoculars if they're good binoculars and you've got good seeing conditions and, you know, when it's a little higher in the sky. So you can see that, you know, in 11 p.m. right now, Neptune is only, 15 degrees above the horizon. I wouldn't bother then trying to catch it then with binoculars. But if you wait until it's highest in the sky before dawn at the present, then you'll have much better odds. So for example, I'll just center this and swing this into the morning sky. So we're going to get it up to 42 degrees. So nice and crisp, clear views of it before dawn if you care to get up early and see Neptune then. But just like everything else, Neptune's going to be available to view earlier and earlier as the weeks pass. So let's see, by the time it gets to opposition, which is going to be happening around September 16th. So let's go to September 16th. And I'll just move back into the evening. So on September 16th, it's going to brighten a little bit to magnitude plus 7.8. It'll be 4.3 billion kilometers away, which is crazy far. 4 light hours of travel time, almost 29 astronomical units distant from the Earth. The best views then will come once it's, you know, sufficiently high. So say 10 p.m., something like that. It'll actually transit after midnight. So if you don't mind staying up, you get a nice view when it's about 40 degrees above the horizon. It'll show a little wee disk about 2.4 arc seconds in diameter. And Neptune has this strangely large moon named Triton, which might be a captured Kuiper Belt object or something that it wandered too close and got nabbed. And so Triton is actually magnitude 13.4. So it actually is within reach of big telescopes. That 11-inch that you were looking through, you might have been able to see Triton. Triton basically orbits the planet like this, sort of anti-clockwise. And you can see there are times when it's closer to Neptune, when it might be kind of lost in the glare of Neptune, and other times where it kind of wanders a little farther. So you get a little bit more separation between them. And opposition, when the planet is closest to Earth, is the optimal time for seeing something like Triton. So that's kind of a bucket list. So Neptune is a bucket list, and then Triton would be a cherry on top for seeing both of them. Let's see, anything else to say about that? Yeah, we'll be able to watch Neptune until about late January, and it'll be kind of reasonably high in the sky for telescopes until definitely the end of December. So keep an eye on that. Uranus is around, but Uranus is another late riser like Mars. So just if you recall, let's go back to tonight. So here we've got Saturn, Neptune, Jupiter, and then Uranus leads Mars up. So those two are hanging around close to one another. Uranus's magnitude of 5.75 is definitely binoculars range, but again, you want to try to get it to a reasonable height above the horizon before you look at it. Nowadays, that means dawn. So if you want to get up early and take a look at Uranus, you can do that. But if you wait until, you know, later in the fall, it'll reach opposition on November 9th, by which point it'll be climbing nice and high in the sky. So let me just center Uranus in our view here. Jump into November 9th. Excuse me. And at that point, it'll be transiting around midnight or so. And so it'll be a nice 62 degrees above the horizon, lots of crisp, clear views, lots of hours to look at it. So a great time to look at Uranus. Uranus has moons as well. You can pick up in a big telescope around opposition time. You could try to see if you can see any of the moons of Uranus as well. Now, another neat thing that's happening with Uranus is that all year long, the moon has been occulting Uranus, but not all of them are visible in Canada. Sometimes they're happening when it's visible in, you know, the Philippines or, you know, Africa or some other place. But there is one coming up that's visible in Canada. So let's see. So on October 10, 11th, 11, 12th. Go back here to 11, 12. Yeah. So on the night of October 11, 12, the moon will be approaching Uranus from the west here. And let's see, with each passing hour, it gets closer. So in the eastern half of the country, there'll be a near miss. So that'll be a disappointing. But let's see, Winnipeg starting around 12:30 a.m. You'll get the occultation. Calgary at 11:14. And let's just simulate one of these so we can show people how that looks. Let's go to Calgary. So here we go, and wind the minutes back. So you'll see that the moon, Uranus, crosses almost the full width of the moon. They'll be nice and high, 31 degrees above the horizon to start with. And then the moon will drift across. So it'll cover the leading lit edge of the moon will cover it first, and then it'll pop out from behind the dark edge of the moon around after midnight for Calgary. So that's something you can put on your calendar. Here's a neat chart. Samantha, you can put it in the chat if you want. So this diagram shows all of the occultations of the moon, occultations of Uranus by the moon this year. So and what you're looking at is there are different symbols here. So when I think it's when you've got the white lines, those are nighttime, and then the dotted red lines are daytime. So we're interested in the nighttime ones. So here we are. Let's see, here's our October 12th. So you can see that the western half of Canada will be nighttime occultation of the moon. And then there's one in November, there's one in December, but these are not visible in Canada. And then there's one that's visible in the daytime in January. So that's kind of a neat. So I think there are something like 13 consecutive months where the moon's going to occult Uranus. Questions? I'll stop for a sec.
I don't see anything right now, but does anybody have any questions before we move on?
Okay, so I think I mentioned looking into the future, a few things to remember in the future. Venus and Mercury close at the end of December. Looking ahead to the next few years for better oppositions of Jupiter, Saturn. Yeah, I think we're good. Yeah. So some tips. Let's talk about some tips for looking at planets. So let's go back to tonight.
One question. Does Uranus have a ring as well?
Yes, it has a ring, but it's not something we can see in an amateur telescope. So
it took us a while to figure that out scientifically. Yeah. So
the main reason for that is that the ring is not reflective. It's not made of reflective icy components the way Saturn's is. It's I think it's primarily composed of more dusty, rocky material. So it's not as high albedo as Saturn's ring.
Thank you.
Yeah, good question. All right. Okay, So a few tips for viewing Saturn. Just get rid of my bookmarks here so we can see everything better. It's always going to look a bit yellowish or creamy colored in the sky. That's one way you could recognize it. I think it's about 17 times fainter than Jupiter is right now. So, you know, you'll see Jupiter is unmistakable, but Saturn will be kind of a modest bright dot, as I said, leading it across the sky. Use about 60 power or 60x to see it. You can crank that up if your seeing conditions are good. Not sure if I've got this set up. So I've got, let's see, I set this up to, this is set to a 6-inch Dobsonian reflector at low magnification, but we can crank this up to say something a little bigger. So, you know, 150x. So if you can go to 60 or 150x, something in that range, you should be able to get good views of it. The other neat thing is that to look for Saturn's moons, if you haven't already done that, highly recommend you take a look at Saturn's moons. Because the planet is tilted, then the moons, unlike Jupiter, where the moons are only kind of a line, the moons of Saturn can appear to the left or the right of the planet, as well as north or south of it. So north, south, east, or west. The dominant moon will be Triton. So Triton is the one with the Earth-like geography on it. It's quite a bright planet, or quite a bright moon, always easy to see. The moons, like Jupiter's moons, they vary from night to night. And Saturn is a great example where you want to take long looks, because as you're taking your long look at the planet, you'll catch glimpses of the little moons, you know, tucked in close. And this is where having Stellarium or a Sky Safari app or you know, Star Walk, one of the good apps showing the planet moon arrangement, is really helps to tell you where to look. You do want to pay attention to the way that your optics flip the planet, though. So, for example, here around now tonight, looking at Saturn. So this would be the binoculars view, which we can't see this magnified. If you're using a Newtonian reflector, it'll flip the image twice. So both in horizontally and vertically. So this is the kind of arrangement you'd get in a Dobsonian telescope or a big reflector. And then if you have a refractor or a Schmidt-Cassegrain, you'll just flip basically east and west, mirror image. So you can use that sort of trick. The way you can set this up in Stellarium, there's a setting to make sure these buttons are available on the toolbar. If you go into your settings, go into your tools, and make sure, maybe it's on extras. It's on extras. Make sure your flip buttons are switched on. So you have those available to help you match your telescope. Let's see what else. The other neat one to watch out for is Yapitus. Where's Yapitus? Here it is. So Yapitus, its orbit is quite large, so it actually takes a long time to change position. But because Yapitus is half light and half dark, can you see how it's getting darker as I advance the date? So there are times where it looks dimmer, and then a few weeks later, it'll rotate enough so that the bright hemisphere appears. So you can look for that as you're watching the planet. Let's see. Yeah, so that's a great thing to check out. The moons of Saturn, just like the moons of Jupiter, can put their shadows on Jupiter. During certain times, the moons can appear on Saturn. And the next time that's going to happen, that happens about every 15 years. So the next time I have that happening is in 2024, October 14th or so. Let's do this. And let's see if I can get the time right. 2 a.m. Can you see the little shadow of Mimas on the planet? So that's kind of another bucket list thing. I've never seen that, but I'm looking forward to giving that a try. That's going to be a toughie, but I'm sure there'll be some of the larger moons may cast their shadows at certain times. Of course, the other cool thing is that this year, the rings are tipped open this much. In the next couple of years, they're going to close up. By the time we get to the spring of 2025, they'll be nearly edge on. Unfortunately, though, the planet will be too near the sun for viewing. So let me just bring this up to, there's March. Around late March of 2025, Saturn will appear to have no rings. So that'll be kind of a fun thing. But as I say, that'll be in the morning sky, too close to the sun for a good look. So if I do this, here we go. So not convenient for us in Canada. But the next one after that will be really good. So December 15th, 2032. And let's bring this up. Oops, no, that's the, oh, that's when they're widest, 2052. So there's that, and let's go back to now. And
we just have a question about, you're talking about moon shadow. Most of Saturn's moons, somebody's asking which moon shadow, but most of them will kind of leave shadows on them, right? Saturn?
I think they all in theory could at different times, and the larger moons will make bigger shadows that are visible. The smaller moons will make shadows that are not really detectable by our telescopes.
So you're just giving one example, but
I was just giving you one example. As we get closer to that sort of epoch, then we'll start reporting on some of these events as they come up. Here's another neat thing. So here's the planet at opposition, right? And if you watch Saturn over the next few nights or next few weeks, you can watch as the sun moves, as the planet moves east of the anti-sun point, the shadow made by the globe of the planet on the rings will get wider and wider. There's a little strip of shadow here, and watch as each night goes by, that shadow gets bigger and wider, that wedge of shadow, as we get past opposition. So if you had been watching it before opposition, you would have seen the shadow on the west side of the planet, but now we're past opposition, so it's on the east side. A couple of tips on filters to use. So if you want to enhance the appearance of Saturn, you can use the Ratten number 21 orange filter to enhance the cloud bands on the globe. The light green Ratten 56 can enhance the cloud belts as well. So that's something you can check out as well. And I'll mention some filters used for Jupiter and Mars here as we go in a little bit. Okay, let's do Jupiter tonight. So we've already talked about some of the things to watch out for in Jupiter.
I just put a link in the chat about the Cassini division that we mentioned earlier as well.
Yeah, I had a diagram for it.
Yeah,
thanks.
The diagram is in.
Yeah, so Jupiter is going to be very easy to locate, very easy to see over the next little while. It's going to reach opposition again in a month from now or so. Any of your binoculars can probably see the Galilean moons. If you've got good binoculars, put them on a tripod if you need to. And of course, you can watch their arrangement vary from night after night. Because the planet's axial tilt is so small, those moons tend to form roughly a line parallel to the planet's equator. You don't need a very big telescope to see the stripes on the planet. So we've got the bands and the belts. The belts are the dark ones, and the bands, the zones, are the light ones. And the belts, the dark ones are you're looking deeper into the planet's atmosphere, and the zones are you're looking more shallowly, the top of the cloud deck. To optimally see it, you want to use about 30x per inch of aperture. So if you've got a 80 millimeter refractor or something like that. It's about a 3-inch telescope. Then about 100x would be an optimal amount. And you can push it beyond that if the seeing conditions warrant that, but that's kind of a rule of thumb. So if you've got a big, nice 6-inch telescope, then you can crank it up to 200x kind of a range. If your seeing conditions are really good, you can start looking for, the little bluish festoons near the belt. You can look for dark spots, which are called barges along the belt. Don't forget that all of this dynamics of the atmosphere is caused by the planet's differential rotation. So the equator of the planet, the weather systems rotate about 9 hours and 50 minutes. And then the equatorial mid-level ones are about 5 minutes slower than that. So this is differential. You can watch for darkening of the limb. So that's by the haze of Jupiter's atmosphere absorbing sunlight. So it'll look a little darker on its edge. Of course, you can look for the great red spot, which I have reports from Frank Dempsey, who's looked at it already this year. He says it's very pale. He noted it was very pale. So maybe it's not a red spot. Maybe it's a, I don't know, salmon spot or some fainter color. It takes about 4 hours, the red spot, to cross the planet, but it's not as easily seen when it's near the limbs. So it's really, 2.5 hours or so of good red spot time. Because the planet rotates once every 10 hours, then the red spot will appear every second or third night from Earth. So if you don't see it tonight, come back in a couple of nights, try again. And you can actually look up when the red spot is visible using an app like Stellarium. You can actually use a tool. So Sky and Telescope has a tool, which I can show, and Samantha can put it in the chat here. I'll bring this over. And this is a good way of calibrating whether your app is right. So you can just go ahead and initialize to today. And it said the great red spot should be crossing the planet on the 16th at 2 a.m. or 2:11 a.m. And again at 12:06 p.m., which is daytime, we can't see. And then at 10:02 p.m., which is before the planet rises. So you really want to look at this, or you can put in a different date. So we could put in, say, tomorrow, calculate tomorrow, and it'll be up at 7 a.m., which is not a great time as well. Let's go a day ahead. Let's go 18th. So 11:40 p.m. on the 18th. Let's try that. On the 18th, 11, and there we go, around 11, 11:14, 11:20, somewhere like that. So if you check your Stellarium or your app, cross-check it with the Sky and Telescope one, and if you're off, the older versions of Stellarium, there's an adjustment you can make, but the newer versions of Stellarium are correct. So Samantha, how does yours look for the, what did we just say?
It does not look the same as yours. I can see the great red spot, but
So 11:40 p.m. on the 18th.
11:40 p.m. 23. Oh, let's see what yours look like. I'll share my screen and I can show you what I see. So we are.
Aha.
So a little bit different.
So you need to adjust it. You can go into the sky and viewing options, F4 on the left. Yep, that one.
F4. Oh, there we go.
Go into SSO tab. And then go down to GRS details. And then you can tweak that first number until you get the red spot in the middle of the planet.
Oh, okay.
Well, the newer versions of Stellarium have fixed this, but the older versions you need to.
And I am actually only one partial version behind what is the latest one. So
Yeah,
I want to move it. So those times are when it's right in the center. So you can kind of want to move it.
That's about right. Yeah.
There.
So now you should be able to use your app, your Stellarium, for until you update it next time to do
Should be
that.
soon now.
Yeah, there you go. Okay, let's wrap up because we've got to get on to our Messier minutes.
Perfect.
So I just wanted to mention that if you want to enhance the views of Jupiter in your telescope, I don't typically use some color filters very much, but you can use the number 56 light green to enhance the reddish bands and the red spot. You can use your number 58 green filter, again, for the bands and spot. A light blue filter can enhance the belt details, the little white ovals, and the number 82, which is very light blue, can do the same. If you have a UHC filter, so a nebula filter, that'll actually enhance the features on the planet. It'll make the planet look a weird color, but you'll see more details on it. And if you're finding the planet looks too bright, if you've got a large aperture telescope and you're kind of being overwhelmed by the brightness of the planet, use a moon filter or a neutral density filter to stop it down, or use the cap. Sometimes you have a lens cap on your telescope with a smaller opening. You can reduce the opening and dim the planet to pick up more details. You know, that's not going to help you with the moons. So you want more aperture and more brightness for the moons, but you want to reduce the glare or the bloat of the image for the surface details on the planet. That'll be true when Mars comes into view as well.
For the great red spot on Jupiter, similar to what we were talking about, the Cassini division, would it also depend on your seeing and those three factors we discussed of what size telescope you could see it with?
Yeah, absolutely. So you want a bigger telescope will let you better see the great red spot. It'll also better let you see the shadow transits. So I've got the next shadow transit on August 20th at 5 a.m. So that's Toronto, that's Eastern time. This would be more in the wee hours of the night for Western Canada. So here you can see the shadow of Europa crossing the planet.
You're not sharing your screen.
Oh, forgot.
I stole it from you. That was my fault.
There we go. Share the screen. Thank you. Yeah, so August 20th at 5 a.m. Then you can see the red spot along with the little black shadow of Europa.
Oh.
Oh, you're back?
Yes, I'm back. I'm so sorry.
That was me. I think that was me.
Oh, I thought it was me.
Okay, let me share my screen again. Oops, I'll just start Stellarium up here. There we go. And share. I don't know if you can hear me, but I'm not. Oops.
Okay. Can someone throw in the chat if you can hear me? Can't hear anything. Is it internet issue? Yes, it looks like. Okay, sorry about that. We were trying to figure out. In the meantime, we have a quick, I apologize. There is a thunderstorm going through southwestern Ontario right now, so I have a feeling that could be something related. We have a quick poll while we're waiting about what we should do after we're done our Messier minutes, because believe it or not, we're almost through all the Messiers. We'll be down around the end of October. So we just wanted to take a poll to see what everybody else was interested in doing. Not saying we're making a decision today what we're going to go on to next, but this is seeing what you would like, and also how you find our resources we have. So if you can take the time just to answer a couple questions while we're waiting for Chris to come back. He is just rebooting his computer. I think everybody can see it. For those of you in our YouTube chat, our programs we have are the finest new general catalog objects. We have the Advanced Lunar Observing Program, Deep Sky Gems, Deep Sky Challenge, Double Stars, which is a new program, so new we're just getting a pin for it. And so put in the chat what you find would be something you'd be interested in. We also were wondering if you are finding our clips that we edit out from our Insider's Guides helpful with the Messier objects, as well as the resources we create about the lists every episode we do. Because if you do, we'll keep on doing them. It's just some feedback. Perfect time, Chris. It was, I thought it was me. It was you.
No, it's me for sure.
My internet was saying I was unstable. We're good. We're doing a little bit of a poll right now, just waiting for some answers while you get settled. Ooh, there's a fight between NGC, Double Stars, and Deep Sky Gems. That's interesting.
I like that you put none in there. I was kidding. I was half kidding.
I said none. I need next year to catch up on observing all the stuff we've talked about, which is fair. Okay. While you get ready for Messier objects, Messier targets, I think we have a Q&A.
Okay. Let's see.
Interesting. Well, somebody has a theoretical thought about, we talk about rings being hard to see around Uranus, but what if we detected another planet with rings circling, like with objects circling it? Will we be able to tell if it would be satellites like the Earth has? So I guess the question is, what would somebody see? What would a satellite, or like if we had enough satellites orbiting around, would they look like rings? It's a really interesting thought. If someone looked outside from far away.
Yeah. I don't think our satellites are kind of coherent enough to form any kind of make that kind of a difference, but that's cool, an interesting idea.
Mm-hmm.
You know, the idea about the Dyson spheres and things like that, right? The ring world idea. That's also a cool thing.
So perfect. Thank you all for answering that survey. That really helps Chris and I kind of discuss where we want to move next. And so for now, we got to talk about some Messier objects before we go. We got 8 to cover.
All right. Let's try this again. Share the screen. Here we go. All right. So this is a great set of Messier objects. Oh, here's the results. Oh,
sorry.
Okay. That's no problem. So we're doing the more northerly summer Messier objects that are visible around now. And the first one I've got up on the screen here is Messier 24. Now, what you're going to see here, if you look to the southern sky in the evening, is you can pick up, I'll just bring up the timing here. Pause my time. This is around 10 p.m. So the sky's starting to get darker, pretty dark by about 10 p.m. You've got your teapot-shaped stars of Sagittarius over the southern horizon, tilting a little bit to the west. And then you've got your Scorpion constellation here on the right of the Milky Way. And the Milky Way rises up like steam from the teapot coming up. And a number of these objects that we're going to talk about are visible to the unaided eye, definitely binoculars, and definitely any size of a telescope. So the first one on the list here is Messier 24. Messier 24 is known as the small Sagittarius star cloud. This one's large and bright, definitely visible with unaided eyes and binoculars. It's about a palm's width to the upper right of the peak of the teapot, right? Or you can aim your telescope or aim your binoculars midway between the stars Polus. There's Polus here. I think it's this one. No, there's Polus and the bottom corner of Scutum, this shield-shaped constellation. This clump of stars is about 10,000 light years away. It's in the next inner spiral arm of the Milky Way galaxy. Definitely low magnification. You know, not all of it's going to fit in your telescope, but when you are viewing it, try to trace out the shape. Look for dark patches within it. So there's some dust that's obscuring some of the stars and make a little bit of structure inside of it. Mini asterisms of the different stars grouping together. Clumps of brightness, sort of little mini star clusters that are inside it as well. There is a glowing H2 region to the lower left here, the southeast of it. And there's actually a couple of little reflection nebulas in here as well that you can take a look at in the southeastern edge. So all of those are kind of upping the ante of different things you can view. This is kind of the anchor point for the other Messiers. So from here, you can actually, once you've found this one, you can just pop a little bit above it and look for Messier 18. Messier 18 is the black swan cluster. It's about 7 arc minutes in diameter. Let's just bring up the telescope view here, and I'll just change the eyepiece to the 25 millimeter Plössl. So you can see it's not a very large object at 35x, but if you can crank your power up, you can see it a little bit better. It's in a less busy area of the sky, but it's easily located just above the small star cluster, small star cloud. And you can also use those two stars, the Polus and Gamma Scuti line, to pick it up that way. You want to look for the star patterns. There are some stars that are a little bit different, a little bit dissimilar to the rest of the star cluster. And there are some prominent blue ones in here that you can take a look for. This is about 4,900 light years away. Next up, and just keep going a little bit higher, is the Swan or Omega Nebula. And this is actually a really nice one to look for with your unaided eyes on a clear, dark night. Has a little bright fuzzy patch in the sky. Binoculars will pick it up. And of course, any size of a telescope. So it's a nice compact hunk of nebulosity in the next spiral arm. It's about 5,500 light years away. It's fairly low in the sky as nebulas go for Canadian observers. So you do want to maybe wait until it culminates. You know, this is transiting around 10 p.m. now, so this is the best time to look at it. And you can see that it's got an internally concentrated patch of brightness that actually gives it the nickname. So if you're looking at it through a telescope that flips it upside down, so a Newtonian, then now you've got the swan shape. So it looks like the swan serenely floating on the pond with the body and the neck. Some people also look at this curved neck and they see the letter omega. So that's where the Omega Nebula comes from, as well as the Swan Nebula idea. When you're looking at it, you can look for, don't magnify it too much. It's a pretty big object. So see how far you can trace out the faint nebulosity around it. You can look for the stars that are internal to it. Some of them are foreground, but some of them are inside the nebula itself. So try to see some of the structural details, the brighter and darker regions. You might even want to sketch it. And if you have filters, you can look for you can enhance it using an oxygen 3 or a UHC filter to brighten the nebula. And also make note of these bright foreground stars down here to the southeast. So that's the Swan Omega. And then from here, we can keep marching upwards. This is going to be a bigger hop. And now you're kind of looking along the base of the shield, a little bit west of the base of the shield for the Eagle Nebula. Eagle Nebula is the nebula that has the famous pillars of creation from the Hubble Space Telescope. And this is much bigger. So you can see in the eyepiece view, it practically fills the eyepiece with a 26 millimeter Plössl at 35x. So that's a great one to not magnify too much. Again, you can see this with, I think you could probably pick it up with your unaided eyes on a good night. You can definitely see it with your binoculars. Definitely try for that. It's about 7,000 light years away, again, in that kind of neighborhood of the inner spiral arm. And again, the UHC or the O3 filter will enhance it. You want to see if you can trace out the wings. So this is the eagle's head and the wings extending east and west. And then the bright central region has a star cluster inside. So you can pick up the star cluster. And then you can note any patterns and things like that that you might see in that object. So that's M16. Now heading back down to the sort of base or starting base of M24, we're going to go east and west to pick up M23 and M25. So M25 is basically just kind of a few degrees or a few finger widths to the left of the star cluster. You can actually, you could use the teapot. So you could kind of put yourself above and between the stars above the teapot. Look at it that way. So in this object, I'll just put it in the eyepiece view for us. So you can see it's a nice open cluster. You can see this with unaided eyes under good conditions, definitely binoculars, although it'll be kind of smaller than the other ones, and any size of telescope. It's about 2,000 light years away. So you want to estimate how many stars you're seeing, the bright ones, the less bright ones. Look for patterns, look for stars that are a little bit different from most. There's a bright pulsating yellow star. Let's see, USGR. So this one, the star, U Sagittarii, is going to be standing out in the kind of the northeastern edge of the cluster. So that's something to watch for as well. Now over to M23, again, that's about a palm's width, I think, to the, not quite a palm's width, a few finger widths, over to the west of M24. And again, you can sort of estimate yourself by kind of almost doubling the line from the peak of the teapot lid up to Polis and then jog a little bit west. And this is a medium-sized open cluster in the telescope. You can see it's not very compact, so it's rather loosely organized. You're going to need to see binoculars. You're going to need to use binoculars for this one, or any size of a telescope. Let's see, it's about 2,000 light years away, again, on that inner arm of the galaxy. So you want to make note of that looseness or degree of concentration, look for star patterns, look for star shapes. Again, look for some stars that are a little bit different and get some counting estimates. You'll also notice that there aren't very many stars around it, and that's because there's some dark dust in this area. So unlike some of the other ones that they're in a busy star field, you might notice this one's a bit of an island when you're looking at it. All right, heading a little bit north from these ones, we're going to head up towards the summer triangle. Here's the corner of the summer triangle up here. So we're going to stop here at the constellation of Scutum. And what I like to do is to find M11, Messier 11. This is the wild duck cluster. Start with Altair. Follow the body of Altair down to his tail, and you're going to see some little stars that form almost a hockey stick. 3 little stars that bend. And if you follow the bend, 1 hop, 2 hop, 3 hop, you're going to be at the wild duck cluster. So this is a real gem. It's small, but it's very bright. You can see in a telescope, It's very, very dense. You can magnify that one up a little bit more and get some more nice detail in it. And in this one, you're going to be looking for, you know, the degree of concentration that it has, its shape. You know, some people have thought they see a V shape in it, maybe hence the flying duck, the wild duck concept. Other people have reported it more like the Borg cube, so maybe more of a boxy shape. You know, around 60 power is a nice combo to use on this one. And finally, we've got Messier 26. So this one's a little bit trickier to find. It's down here inside the shield itself. What I recommend is using Alpha Scuti, which is a fairly reasonably visible star. And then from here, dropping down to the southeast, looking for Delta, and then kind of taking that and then 50% of that in the same direction, pick up M26. So M26 is magnitude 8. It's a pretty good in binoculars or any size of a telescope. Again, here's the Dobsonian view. So it's smaller and fainter than the other ones we've looked at. But it's a nice little treat to magnify up. And again, it's kind of hollowed out. So it doesn't have more stars in the middle than the other ones do. So you're going to notice lack of stars in the center. Look for its shape and patterns and star types that might be a little bit different. So those are some of your some of the best of Messier for the summertime months.
Awesome. Just a reminder to everyone that that full list is at the link ras.ca/Messier -minutes, including all the notes, what Chris said to look for in it. And a couple minutes past 5. So thank you for being patient with all the technical difficulties today. We apologize. Well, the chat went wrong and both of us kind of had some issues, but that's okay. We hope that you enjoy the rest of August. We will be back September 13th. The schedule is up on ras.ca/insiders guide. And we are going to be doing variable stars, right? I think that's
the plan.
So, and finish up the summer Messier. So thank you so much for joining us.
Yeah, we only have three more sets of Messiers and then we're done. Which you probably said while I was busy rebooting my computer.
Yeah, that's how we start, but it's all good. People are hungry for more after that. So,
all right. Well, enjoy the planets, everybody. Hope you can get some shots, get some views of them, and we'll see you in a month.
Keep looking up.
Keep looking up.